Alright, hello computing students, Mr. Holmes with another video. In this video we're going to look briefly at some of the binary calculations I'll be expecting you to be able to do. At year 7 I expect you to be able to work with 4 bits as a minimum, so that's what I'm going to focus on in this video. If you can figure out how to work with 8 bits or more, that's brilliant. Please do continue to work with the binary number system. Right, so binary, of course, is a base 2 number system, and so the calculations we need to be able to do is to convert the two things, decimal numbers to binary and vice versa, binary numbers back to decimal. So we're going to look at two examples. Our first example, we're going to look at converting 13 into a 4-bit binary number. So to get things started, you should always start off by drawing yourself up a little table, and in this table we are going to number the place values in the binary system. Remember, our first digit always is a unit, so it starts with 1. In the binary system we multiply by 2 as we move from right to left for our columns. So 1 times 2 is 2. So the next column up, I'm going to go 2 times, I'm just going to double the 2. 2 times 2 is 4, and then finally 4 times 2 is in fact going to give me 8. So those are my 4-bit, that's my 4-bit column pattern, and this will always be the same, but you should understand how to work it out as well. I wouldn't just learn it. So without further ado, let's get going. So what I now need to do is I need to take my number 13 and I need to break it up so that I can write it as the sum of 8, 4s, 2s and 1. So I begin by asking, can I use an 8? The answer is yes, I can. It's the biggest digit that I have. I'm going to try and use that. And yes, indeed, I can in fact use the 8, which then in turn leaves me an answer of 5 left over. So all I've done here to work out what to put in the 5 over here was I've taken away 8 from 13. So it's a little bit like taking 8 away from 10, which is going to give me the answer 2, and then I've got 3 more above 10, so the 2 plus the 3 gives me the 5. That's how I work out the 5 left over. So moving on, I now need to further, because 8 is one of my digits but 5 is not, so I keep going. Can I break the 5 down using 4s, 2s and 1s? And the answer is yes, I can. In fact, so the 5, I can use the 4, I can use the next most, and 5 is 4 plus 1. And there we go. So what that in turn means is that I'm going to break down and 13 into 8 plus 4 plus 1 using this this table. So which means in turn that I need to turn the 8th bit unit on, so I put a 1 in that box. I'm going to use the 4, so I turn the 4-bit value on, put a 1 in there. 2, no, I have no 2, so I put a 0 in there because I'm leaving it off. And finally, yes, I do need the 1, so I put a 1 in there, and that in turn gives me my final answer. And I should just be particularly correct about how I write down that answer. So I would simply say, right, so 13 is equal to, going from left to right, it's going to be the binary number 1101. That's my binary number. I'm going to put in brackets a little 2. I'm going to put a 2 in brackets after it so that I'm clear that 13 is not equal to 1101, and what I am saying is that 13 is equal to the number, the base 2 number, the binary number 1101. Right, moving on now to my next example. I want to convert the binary number 1011 into decimal, and as before we start with our table. So the first bit position value is a 1. I double the 1 to give me a 2. I double 2 to give me my next value, which is going to be 4, and I double the 4 to give me my next value, which is 8. All I do now is I fit my bit pattern in. So from left to right, I put in a 1, a 0, a 1 and a 1. So that's exactly in the right order of when I fit it in. The calculation, extremely simple. Let's have a look at that. So alright, let's get that nice and big. Right, so 1011 base 2 in fact means, what does it in fact mean? It means I simply go through my columns and write, have I turned that bit pattern on? Have I turned the 8 on? Yes, I have. So I'm going to have an 8. What about the 4? Have I turned that on? Well, the answer is no, I haven't. So I'm just going to write a 0 down there. In other words, I'm going 1 times 8 is 8, 0 times 4 is 4. Because I'm always multiplying by either 1 or 0, I'm just going to get the answer above the column, the place value of the column above it. 1 times 2 is a 2. I'm going to have a 2, and finally a 1 times a 1 over here is going to in fact give me a 1. And this in turn is equal to none other than, well, quite a simple calculation now. 8 plus 2 is 10, plus 1 is 11. So there we have it. The binary number 1011 is equal to the decimal number 11. Notice I haven't put any 2's or anything after it. If I wanted to put a base in, I could be exact and put a 10 rather after it to represent base 10. But by default, or the assumption that we make is, if we're working in decimal, we don't have to put the base or the value in brackets after the base value, or the digit count value after the number. Alright, that ends this video on binary and decimal calculations. Thanks for watching. Mr. Holmes signing out.